Oh, this is James Jopling with Shoppa's John Deere. These are our 2022 Tractor Technician Contest components. The first of which is just digital multimeter, and the first question is, this is an auto-ranging multimeter. No, you've got to actually manipulate the dial for the settings, so that's false. A digital multimeter and an analog meter have the same impedance. That is incorrect, so that's false. The resistance of the test leads has no bearing on displayed values. That's incorrect also. That's false, because you are going to have a little bit of resistance in the leads themselves. The next question, a DMM and a DVM have all the same functions. A DMM is a digital multimeter. You have got many different applications for that. A DVM is a digital voltmeter, and that's all it is. It's just indicating voltage. And when testing amperage, one should start at the lowest setting first. No, you should always start at the highest setting. That is all for our first component. Our second component is relay. Okay, a relay, this is a common automotive relay, and it's utilized in tractors also. A relay is an electrical device which uses a high amount of current to activate a coil to move contact points. It's quite the contrary, quite the opposite. It uses a low amount of current to activate the coil. So that's false. When the coil is activated, higher current will be transferred through both contacts 87 and 87A. That's inaccurate. That would be 30 and 87A. This is described as a single pole, single throw relay. That's false. It's a single pole double throw, meaning that there are two different contact points within the relay itself. So when it's not activated, one point will be contacted. Then when coil is activated, the second point will be contacted. Next question, when voltage is applied to poles 85 and 86, the coil is activated. Contacts will be to terminals 30 and 87, that's true. And the last question, the coil is within specification of 23 to 28 ohms. Now we're going to set our meter to resistance, 200 ohm scale, and we will check it. This is displaying 0.7, 0.8 ohms. So that's false. And that is all which we have for the relay. Okay, our next component is a speed sensor. And this is a relatively common speed sensor. It's utilized in many industries. So, it's not John Deere specific. So the first question is, if the tone wheel sensor clearance is 0.800, that's 8/100ths of an inch, the speed indicated will be higher than actual. That's false. Actually, it would be opposite. It may not indicate the correct speed. Next question, the resistance of the sensor is within specification. If we look, let me set this to, okay, it should be somewhere approximately 3 kilo ohms, 3,000 ohms. But you notice that it's indicating that there's no resistance whatsoever. So this is not within specification. That's false. If any metallic debris is collected in the sensor, this will not influence the reflected speed. That's actually a small magnet in there, and it will collect material and it will affect the indicated speed. Next question is, if the internal coil resistance is out of range, the sensor will still indicate proper speed. That's also false. And the last question concerning this If a gear tooth is missing, the sensor will still indicate the correct speed. That is incorrect. That is false. That is all of which we have for our speed sensor. Okay, our next component is one of my favorites, a GPS receiver. Now, this, the first question on this receiver is only one satellite is required to pinpoint your location. That is inaccurate. You must have a minimum of 3 satellites to pinpoint your location. And actually, right now, with the constellations of which we have approximately 28 satellites at any time for calculations. So the accuracy level is much greater. Next question, GPS is an acronym for U.S. Global Positioning System. That's true. The next question, the derived locations of GPS receiver from transmitting satellites is triangulation, not trilateration. That's false. It's actually trilateration, not triangulation. Next question, trilateral calculations are only utilized with automobiles. That's inaccurate. This is for a piece of farm equipment. So all GPS receivers actually have trilateral calculations to derive your specific location. And the next question, all satellites are orbital. That is inaccurate. We have 3 geostationary satellites over the continental United States, and one is for the eastern, one is for central, and one is for western. And those geostationary means that they are at the same position over the Earth at all times, and all others are orbital. That is all for our GPS receiver. Our next component is just a simple tire. This came off of a small lawnmower, but every tire you can actually have the same effect with. Okay. First question, a rubber tire is not an absolute insulator. That's true. We have power supply going to the tire, we have the ground, and then we have our meter hooked up. We've got a safety pin stuck in here. It's indicating very, very close to source voltage. Now you ask how that's possible, and we'll get to that in one of our next questions. But it is not an absolute insulator. Next question, testing with DMM from battery positive to outside tire. Voltage is displayed due to electromagnetic transfer. That's incorrect. That's false. Next question, concentration of carbon black will not determine conductivity. And keyword will not. Okay, that's false. The higher the level of carbon black within the composite, and that's one of the mixtures when they have a tire, not only rubber, this is not true rubber, it has carbon black mixed in. So the higher the concentration of carbon black, of course, it will influence the conductivity. Next question, the voltage indicated is due to a natural high density of rubber. No, that's false. Now there again, carbon black is in the composite. The last question, with carbon black in the composition, this is similar to a resistor in an electrical circuit. That is absolutely correct. That is why you're actually indicating voltage. There's not much current. There's practically zero current being transferred through this, but there you will indicate voltage. And that is all of which we have for our tire. Our next component is a battery. Just very simple, very basic. This is used in many different applications there again. The first question is each cell has potential of 12 volts. That is inaccurate. That's incorrect. Each cell will have potential of 2 volts. And so you notice that there are 6 cells on this. This will be a 12 volt battery. The next question, if starter requires 950 amps and the machine electrical system requires an additional 100 amps, this single battery should be sufficient for starting. That is very, very inaccurate. This battery has a total of 925 cold cranking amps. So this battery would not be adequate for that. The next question is CCA is an acronym for continuous cranking amps. That's false. It's cold cranking amps. Next question, the concentration of sulfuric acid within each cell is important. That's true. And the last question, cold and extreme hot temperatures will not require more amperage. There again, keyword will not. So and in cold weather and extreme hot, you will require more amperage to, say, start the machine. And that is all which we have for the battery. Okay, now this is our first electrical board. And the first question on this, the total of all meters displayed voltages should be greater than source voltage. Display voltage is voltage drop through each component. So display voltage should be greater than source voltage. That's wrong. That is inaccurate. So that's false. And next one, the entire circuit is fuse protected. That's correct, because here's your power providence. It's coming in, going through the fuse, and it will go through this switch. This is a parallel circuit. That's not correct. This is actually a series circuit. Yeah, we'll be coming here to that one, this, and then to ground. So it's a true series circuit all the way. Bulb B is not illuminated due to lack of current. That's true. What is going on is we have our power providence coming, going through this bulb and C bulb, and there's only a small pathway of which the current can flow. So it's actually restricting the current. Therefore, that's keeping that from being illuminated, this large bulb, which is an 1156 bulb. And the next question, the bulbs C1, B, and C require equal current for proper illumination. There again, this being 1156, the filament is much larger, therefore it requires much greater amount of current to illuminate that. So that's false. That is all of which we have for this particular board. Okay, on this electrical board, this is our second of 3 of them. The first question is all circuits are not fuse protected. That's false, because here again we're coming through the fuse and then going through our switch, and actually they are all fuse protected. Now this circuit is coming directly to the ground. This is ground, not your positive power providence. But anyway, this next question, with the switch off, only one LED on board M is illuminated due to a second LED probably being faulty. That's inaccurate. LED is an acronym for light emitting diode. A diode only allows current flow in one direction. So if we were to reverse these leads, the second LED would illuminate and that would not be illuminated. The next question is also false. With the switch on, bulb B is not illuminated to the bulb on board C is using all available current. That's inaccurate. That's incorrect. We are flowing current through here, and then we'll be going to ground. This is a ground completion circuit. There again, such as on the other board, we have current limitation due to the size of the filament within this bulb. So there's inadequate current to illuminate this bulb. Next question. All circuits are parallel. That's inaccurate. These are series circuits. The last question, if the relay coil will fail in board J with the switch on, only lamp on board C would be illuminated. That is false. That completes this board. This is our last electrical board. The first question statement, with the switch on board A off, and that's off, voltage is noted to contact 87A of the relay, however not noted on the lamp on board C or LED on board O. The issue is probably with relay. That is false. You're displacing voltage through all the way to here, and this is a constant power, 87A, coming to the diode. Now, one thing about a diode is you can tell by the line on the end, that's blocking current. That's blocking current flow there. And that is why we're not getting any voltage displaced, no current, no voltage displaced to either one of these. So that's false. The next, with the switch on board A on, only LED on board O is illuminated. However, lamp on board C is not illuminated due to faulty bulb on board C. That is incorrect. With switch on board A off, power is noted contact 87A from relay, however not noted on bulb C or LED O. The issue is with diode. There again, it does come down to the diode, and it's hitting that little wall on the diode. It will not allow current flow. The next is all circuits are in series. That's true. That's true. Just the relay is changing a portion of the circuit as to where, you know, you're going to go from one series circuit to another series circuit. And the next, both circuits are controlled by switch on board A. That's correct, because you're utilizing the switch just to control the relay to direct current flow, voltage, to each one of the circuits individually. So that's true. That is all the questions on this.